of controls in the Java X.Swing package. Input components: button, text, menu, slider, JCombo box, list. Now, information display components are JLabel, JProgress bar, and JComponent set tooltip text. Chooser components are file chooser, color chooser, that is J file chooser, J color chooser. More complex displays are J tables, J table, J tree. Inheritance. Inheritance is one of the cornerstones of object-oriented programming because it allows the creation of hierarchical classification. In the terminology of Java, a class that is inherited is called a superclass. A class that does inheriting is called subclass. Therefore, a subclass is a specified version of a superclass. It inherits all of the members defined by the superclass and adds its own unique elements. Inheritance basics. To inherit a class, you can simply incorporate the definition of one class into another by using extends keyword. To see how it will begin with an example. The following program creates a superclass called A and a subclass called B. Notice how the keyword extends is used to create a subclass of A. Here is the example where you have class A, B extends A. Have a look over it. The output of the program has been given. As you can see, subclass B includes all of the members of its superclass A. Subclass can access I and J, called show ij, and also some I and J can be referred to directly as if they were part of B. Even though A is a superclass for B, it is also a complete independent standalone class. Being superclass for a subclass doesn't mean that the superclass cannot be used by itself. Further, a subclass can be a superclass for another class. The general syntax for class declaration that inherits a superclass is shown here. Member access and inheritance. Although a subclass includes all of the members of its superclass, it cannot access those members of the superclass that have been declared as private. For example, consider the following simple hierarchy. In a class hierarchy, private members remain private to their class. This program will not compile because the use of J inside some method of B causes a access violation. Since J is declared as private, it is only accessible by other members of its own class. Subclass has no access to it. So this is the example. Next, using super. Whenever subclass needs to refer to its immediate superclass, it can do so by use of keyword super. Super has two general forms. The first calls the superclass constructor. The second is used to access a member of the superclass that has been hidden by a member of a subclass. Using super to call superclass constructors. A subclass can call a constructor defined by its superclass by use of the following form. The syntax has been given. Here arglist specifies any arguments needed by the constructor in the superclass. Super must always be the first statement executed inside a subclass constructor. Next, superclass constructor. When we go for superclass constructor, now we have box weight. Uses super to initialize its box attributes. Box weight extends box. Box weight has all these functions. This calls superclass constructor. Box weight calls super with the arguments w, h and d. This causes the box constructor to be called, which initializes with height and depth using these values. Box weight no longer initializes these values itself. It only needs to initialize the value unique to it. This leaves box free to make these values private if desired. The example program has been given for your reference. Super. Notice that super is passed on object of type box weight, not of type box. This still invokes the constructor box of box OB. As mentioned earlier, a superclass variable can be used to reference any object derived from that class. Thus, we are able to pass a box weight object to box constructor. Of course, box only has knowledge of its own members. Second use of super. The second form of super acts somewhat like this, except that it always refers to the superclass of the subclass in which it is used. This has the following general format. Here, member can be either a method or instance variable. The second form of super is most applicable to situations in which member names of a class hide members by the same name in superclass. Now, you consider this class hierarchy and go with to overcome this. Next, using super to overcome name hiding. Consider this example where B extends A, where I hides the I in A. So this is what super does. You have an example for that. Creating a multi-level hierarchy. Given three classes called A, B and C. C can be a subclass of B, which is a subclass of A. When this type of situation occurs, each subclass inherits all of its traits found in all of its superclasses. In this case, C inherits all aspects of B and A. When constructors are executed. When a class hierarchy is created, in what order are the constructors for the classes that make up the hierarchy executed? For example, given a subclass B and a superclass called A, is A's constructor executed before B's or vice versa? Answer is that in a class hierarchy, constructors complete their execution in the order of derivation from superclass to subclass. Further, since super must be the first statement executed in a superclass constructor, this order is same whether or not super is used. If super is not used, then default or a parameterless constructor of each superclass will be executed. Now you have an example for this. Next it is method overriding. In a class hierarchy, when a method in a subclass has the same name and type signature as a method in its superclass, then the method in the subclass is said to override the method in the superclass. When an overridden method is called from within its subclass, it will always refers to the version of that method defined by the subclass. This version of method defined by subclass will be hidden. You have an example for it, where show is invoked on an object of type B. The version of show defined within B is used. That is, the version of show inside B overrides the version declared in A. If you wish to access the superclass version of an override method, you can do so by using super. For example, in this version of B, the superclass version of show is invoked within the class version. This allows all instance variables to be displayed. It is given here with super. So method overriding occurs only when the names and type signatures of two methods are identical. If they are not, then two methods are simply overloaded. For example, consider this method version of the preceding, modified version of the preceding example. Next, dynamic method dispatch. Method overriding forms the basis for one of the Java's most powerful concept, dynamic method dispatch. Dynamic method dispatch is the mechanism by which A call to an overridden method is resolved at runtime rather than compile time. Dynamic method dispatch is important because this is how Java implement runtime parallelism. When different types of objects are referred to, different versions of an overridden method is called. In other words, it is a type of object being referred to that determines which version of an overridden method will be executed. Therefore, if a superclass contains a method that is overridden by a subclass, then when different types of objects are referred to through a superclass reference variable, different versions of the method are executed. You have an example to go with. Applying method overloading. Let us look at more practical example that uses method overriding. The following program creates a superclass called figure that stores the dimension of a two-dimensional object. It also defines a method called area that computes the area of an object. The program derives two subclasses from figure. The first is rectangle and the second is triangle. Each of these classes overrides area so that it returns the area of a rectangle and a triangle respectively. The example has been given and the output of the program has been given. Using abstract classes. You may have methods that must be overridden by the subclass in order for the subclass to have any meaning. Consider the class triangle. It has no meaning if area is not defined. In this case, you want some way to ensure that a subclass does indeed override all necessary methods. So we go for abstract method. You can acquire that certain methods to be overridden by subclass by specifying the abstract type modifier. These methods are sometimes referred to as subclasses responsibility because they have no implementation specified in the superclass. Thus, a subclass must override them. It cannot simply use the version defined in the superclass. To declare an abstract method, use this general form. Any class that contains one or more abstract methods must also be declared abstract. To declare a class abstract, you simply use the abstract keyword in front of the class keyword at the beginning of class declaration. There can be no objects. There can be no objects of an abstract class. That is, an abstract class cannot be directly instantiated with the new operator. Such objects would be useless because an abstract class is not fully defined. Also, you cannot declare abstract constructors or abstract static methods. You have an example for this. No objects of class A are declared in the program. As mentioned, it is not possible to instantiate an abstract class. One another point, class A implements a concrete method called callMeTo. This is perfectly acceptable. Abstract classes can include as much implementation as they see fit. Although abstract classes cannot be used to instantiate objects, they can be used to create object references because Java's approach to runtime polymorphism is implemented through the use of superclass references. Thus, it might be possible to create a reference to an abstract class so that it can be used to point a subclass object. This is demonstrated in the example. As the comment inside, main indicates it is no longer possible to declare objects of type figure since it is now abstract and all subclasses of figure must override area. To prove this to yourself, try creating a subclass that does not override area. You will receive a compile time error. Although it is not possible to create an object of type figure, you can create a reference variable of type figure. This variable figref is declared as a reference to figure, which means that it can be used to refer an object of any class derived from figure. As explained, it is through superclass reference variables that overridden methods are resolved at runtime. Use final with inheritance. The keyword final has three uses. First, it can be used to create equivalent of named constant. The other two uses of final apply to inheritance. To disallow a method from being overdone, specify final as modifier at the start of a declaration. Method declared as final cannot be overridden. The following fragment explains this. Late binding, early binding. Methods declared as final can sometimes provide a performance enhancement. The compiler is free to inline calls to them because it knows they will not be overridden by a subclass. When a small final method is called, often a Java compiler can copy the bytecode for the subroutine directly inline with the compiled code of the calling method, thus eliminating the costly overhead associated with the method call. Inlining is an option only with final methods. Normally, Java resolves calls to methods dynamically at runtime. This is called late binding. However, since final methods cannot be overridden, a call to one can be resolved at compile time. This is called early binding. Use final to prevent inheritance. Sometimes you will want to prevent a class from being inherited. In such cases, you can precede the class declaration with final. So, declaring a class as final implicitly declares all of its methods as final. As you might expect, it is illegal to declare a class both abstract and final, since an abstract class is incomplete by itself and relies upon its subclass to provide complete implementation. Here you have a final class. Then, next, packages. Packages are containers for classes. They are used to keep the class name space compartmentalized. For example, a package allows you to create a class name list which you can store in your own package without concern that it will collide with some other class name list stored elsewhere. Interfaces. Java allows you to fully abstract an interface from its implementation. Using interface, you can specify a set of methods that can be implemented by one or more classes. In a traditional form, the interface itself does not actually define any implementation. Although they are similar to abstract classes, interfaces have an additional capability. A class can implement more than one interface. By contrast, a class can only inherit a single superclass. To create a package quite easy, simply include a package command as a first element in your Java source file. Any classes declared within that file will belong to the specified package. The package statement defines the namespace in which classes are stored. If you omit the package statement, the class names are put into default package which has no name. This is the general form of package statement. Java uses file system directories to store packages. Classes you declare to be the part of my package must be stored in your directory called my package. You can create a hierarchy of packages which has been showed. Finding packages in class. The Java runtime system uses the currently working directory as its starting point. Thus, if your package is in a subdirectory of the current directory, it will form. Second, you can specify a directory path or paths by setting the class path environmental variable. Third, you can use the class path option with Java and Javac to specify the path of your class. We have a simple package program to go with, and the explanation has been given. These are the different class member access with their access specifiers. Java includes the import statement to bring certain classes or entire packages into visibility. Once imported, a class can be referred to directly using only its name. The import statement is a convenience to the programmer and is not technically needed to write a complete Java program. If you are going to refer to a few dozen classes in your application, However, the import statement will save a lot of typing. In Java source file, import statements occur immediately following the package statement and before any class definition. General form is given. All of the standard Java classes include with Java are stored in a package called Java. The basic language functions are stored in a package instead of Java package called java.lang. It has been imported. You either specify an explicit class name or a star, which indicates that Java compiler should import the entire package. You have a small example using packages. As you can see, the balance class is now public. Also, its constructor and its show method are public too. This means that they can be accessed by any type of code outside the MyPack package. Here is another example. As an experiment, remove the public specifier from the balance class and then try compiling test balance as explained. Error will result. Interfaces. Interfaces using the keyword interface. You can fully abstract a class interface from its implementation. That is, using interface, you can specify what a class might do, but not how it does it. Interfaces are syntactically similar to classes, but they lack instance variables, and as a general rule, their methods are declared without any body. Any number of classes can implement an interface. Also, one class can implement any number of interfaces. Java allows you to fully utilize one interface multiple methods aspect of polymorphism. You have a diagrammatic representation for understanding relationship between classes and interfaces. This is a simple example where you come across with interfaces. Multiple inheritance in Java by interface. If a class implements multiple interfaces or an interface extends multiple interfaces, known as multiple inheritance. You have an example for it. Defining an interface with general syntax. An interface is defined much like a class. This is a simplified general form, and here is an example for it. Implementing interfaces. Once an interface has been defined, one or more classes can implement that interface. To implement an interface, include the implements class in the class definition and then create the methods required by the interface. The general form has been given. An example of it has been given for your reference. Nested interfaces. An interface can be declared a member of a class or another interface. Such an interface is called member interface or a nested interface. A nested interface can be declared as public, private, or protected. This differs from a top level interface, which must be either declared as public or use the default access label. An example has been given. Notice that A defines a member interface called nestedif, and that is declared public. Next, B implements the nested interface by specifying implements a.nestedif. Notice that the name is fully qualified by the enclosing class name. Inside the main method, an a.nestedif reference called nif is created, and it is assigned a reference to a B object. Because B implements a.nestedif, this is legal. Interfaces can be extended. One interface can inherit another by use of keyword extends. The syntax is same for inheriting classes. When a class implements an interface that inherits another interface, it must provide implementation for all methods required by the interface inheritance chain. Here is an example to show with it. Static method in interface. The example has been given for this. Then difference between abstract class and interface has been tabulated for your reference. An example has been given, creating interface that has 4 methods to go with.